Hi everyone. I just wanted to come really quickly and let us look at some examples from section 8.3 that will help you to complete the homework. Section 8.3 discusses finding the area and perimeter of polygons as well as the area and circumference of circles. In this first example, we are asked to find the circumference and the area of the circle. So let's go ahead and work this first example. You'll notice that this circle has a radius of 5 inches. So I'm going to draw this on the whiteboard. And again, we have the circle with the radius of 5 inches. If we want to find the circumference of a circle is expressed by the formula 2 pi times the radius. So to find the circumference of this specific circle, we would multiply 2 pi times 5 inches. If we are asked to express the circumference in exact measurement, it would be expressed by 2 times 5, which is 10 pi inches. Or we could find the decimal approximation by doing the calculation on the calculator where we will actually key the pi button. I was trying to see if perhaps I had the calculator on my computer, and I do not. So I'll just tell you which buttons I'm pressing. So we would press 10, and then the pi button is located above the division key on the calculator. To access the pi button, because it's written in blue, you will have to press the second button first. So I will press second, and then the button above the division symbol, which I call the caret top, to get pi. And 10 times pi gives us a decimal approximation of about 31.4159 inches. And depending upon the problem, they might ask us to round to 2 decimal places. And if we rounded to 2 decimal places, we would express the circumference of this circle as approximately 31 and 42 hundredths of an inch. That is the circumference. Using this same example, let's find the area of the circle. Again, the circle has a radius of 5 inches, and the formula for the area of a circle is pi times radius squared. So the area of the circle will be expressed by pi times 5 inches squared. The exact area in terms of pi would be 5 squared, which is 25, times pi inches squared is a unit of measure. And then the decimal approximation we'll find the same way that we did before, using our calculator and the pi button. And the decimal approximation is 78, and rounded to 2 decimal places, it's 78 and 54 hundredths of an inch squared. Let's do another example. I'm going to pull another example from the homework. So let's see what we have. This example asks us to find the area of the shaded region. So if we look at the picture, we have a circle, the larger circle, which it would be the pink one, that has a radius of 15 meters, and then the smaller circle that we're going to remove, or the white one inside, has a radius of 13 meters. So I'm going to recreate this drawing on the whiteboard. We have a circle, and then we have another circle inside the circle. I believe that This was 15 meters. And I believe the other was 13 meters. Let me just revisit the picture just to make sure. Yes, okay. So here's what we have. We want to find the area of the shaded region, and again, this was the region that was shaded. It's kind of like a donut, okay? So I'm going to refer to it as a donut. So let's talk about what's happening here. This is the same thing as the whole donut with nothing missing in the middle. The whole donut, okay? The area of the whole donut. And the whole donut has a radius of 15 meters. And then we're going to remove the donut hole. So we're going to take out of the middle of this donut the hole, okay? And the donut hole that we are removing has a radius of 13 meters. So we want to find the area of the donut that remains once we remove the hole or the center from it. We need to find the area of the larger circle minus the area of the smaller circle that we've removed from the middle. Again, the formula for the area of a circle is pi r squared. The area of the larger circle, which should be shaded in the pink or the red, would be found by pi. The radius is 15 meters squared. And then we're going to take away from it the part that we are removing. We are taking out or cutting out or removing the donut hole, the part in the middle. And so then we're going to be left with just the area of the donut that we would eat, minus the donut hole. So that area of the donut hole in the middle would be found by pi times 13 meters squared. And we can put this all on our calculator. And if we do so using the pi button again, we would have pi times 15 squared gives us approximately an area of 706 and 858,000 meters squared minus the area of the donut hole, which is 13 squared times pi, and that area is 530.929 meters squared. And then we'll go ahead and subtract these two numbers or find the difference of them. And it's approximately 175 929 thousandths meters squared. And that's the approximation. And so again, I use a little squiggly equal signs to represent its a rounded or approximation. Let's do another example. Let's try to find one that doesn't involve a circle. So again, I'm going back to your homework and I'm going to pull up another example. I'm going to skip through several of these until I find one that doesn't involve a circle. Maybe one that has a different type of shape in here. I want one that's a composite figure, one that's a little more complex than just and less straightforward than just finding the area of a polygon. Let's do this one. This one says we want to use the Pythagorean theorem to find the length of the unknown side and then find the perimeter and area of the triangle. And here is the actual drawing that's provided by your textbook. Okay, again, I'm going to recreate this on our whiteboard. We had our right triangle that had a leg of 12 kilometers and a hypotenuse of 37 kilometers. The Pythagorean theorem tells us that the sum of the legs squared is going to equal the length of the hypotenuse squared. Remember in your right triangle that the legs are formed or adjacent to the right angle, and it makes an L that can indicate the legs. And the right angle is an arrowhead that points to the hypotenuse. Okay? So we are looking for this missing side, this leg. I'm going to use the Pythagorean theorem and substitute in the values. One of the legs is 12 kilometers squared, so 12 kilometers, not squared, excuse me, 12 kilometers, and then we want to square it, plus the missing leg, it's going to equal the hypotenuse squared. 12 squared is 144, so we have 144 kilometers squared, plus x squared is going to equal 37 squared, which is 1,369 kilometers squared. And again, if we want to solve for x squared, we have to do the inverse operation of addition, which means we will subtract 144 kilometers squared from both sides. (144 kilometers squared minus itself is 0, and we will be left with x squared equals the difference of 1,369 and 144 is 1,225 kilometers squared. To find what x is, the inverse operation of raising something to a power of 2 is to take the square root. So we will take the square root of both sides. And we find that the length of the missing side in this triangle is 35 kilometers. Now we have to use this piece of information to find the perimeter and the area of the triangle. I'm going to clear the board and redraw our diagram using the side that we just found. So again, we have this right triangle that had a hypotenuse of 37 kilometers. This side or leg was 12 kilometers, and we found the missing side of 35 kilometers. So if we want to find the perimeter, you just add the distance around the edges. So we would find this by finding the sum of 12 plus 35 plus 37, and our units would be kilometers. So the perimeter of this triangle is 84 kilometers. And its area, the formula for the area of a triangle, if we know the height, is 1/2 the base times height. So it would be found by 1/2. The base of this triangle is 35 kilometers, and its height is 12 kilometers. So the area of this triangle was 210 kilometers squared. I will continue more examples in a second part to this video.